Good afternoon. My name is Kyle Houchins. I'm a tech and a trainer for McNeil, and this is Getting Started Rhino for Windows version 8. Version 8. Woo! For those of you who don't know, version 8 has been released, is available now. We did a soft launch on Halloween, and it is available now. The public launch is somewhere in the end of November, and we will be doing that thing publicly. But if you go to our website right now, Rhino 8 is actually available. What we're going to do today is talk about one of the coolest features in Rhino 8, which is Shrinkwrap. And Shrinkwrap is a godsend if you are a jeweler, if you do 3D printing, if you have to shell stuff, if you have to manage mesh stuff, right? I did a video a while ago on our YouTube, which is called Never Fail Shelling. The same model. I like this model just because it's fun. And the cool thing about it is it's actually kind of a nightmare to try and shell this thing. So what I wanted to show today was not only the power of shrink wrap and shelling things, but I wanted to show you how to create a lap joint, which has been something in the past that has been a complete and utter pain in the butt in order to be able to do. First of all, shelling in Rhino, if you've ever tried to shell anything in NURBS, you know the pain. The video Never Fail Shelling on YouTube is it basically shows the process, and you can either shell in NURBS, you can shell you can end up with a NURBS result, or you can end up with a mesh result. For this particular demo, what we're going to do is assume that this is going to be a mesh result that we're going to go for 3D printing. Now, shrink wrapping this and splitting it in half is a piece of cake, right? Because one of the things in version 8 that's kind of an unsung hero that we haven't talked about a lot yet is the fact that the mesh booleans, for the first time in Rhino's history, actually work. They've been rewritten from scratch by one of our brilliant devs named Julio, and the mesh booleans work, mesh trimming works, mesh splitting works, all that kind of stuff. So if you've ever tried to do any mesh stuff in Rhino before and have beaten your head against the table, like I have, I ran a consultancy for 20 years before I started to work for Rhino. And so I've done a lot of this stuff in production. Most of my experience was in the toy industry. And so I was always trying to do stuff like this where a client would call me and they would say, hey, we got this great model. We need to shell it. We need to print it. And then we need to be able to put some stuff in it. And I would say, great, I have to charge you to build the model twice, because trying to shell something in NURBS was an absolute positive nightmare. And so what I want to show today is shrink wrap. And shrink wrap is actually based on voxel technology. And so it doesn't fail, which is a bold statement, but I'm going to stand by it because it's true. So let's just run it. And we're just going to run shrink wrap. I'm going to select this object here. And we're going to run shrink wrap. And the first thing that you'll see is if we preview this, what it's going to do is it's going to take, first of all, let me back up a second. This model is kind of a piece of crap, really, if you look at it. It's made up of a bunch of pieces that are stacked on top of each other. This is a surface, these are surfaces, all of this stuff is separate pieces. This is junk, this is junk. There's stuff that's open, and there's things that are just overlapping and stuff like that, right? So it may look good, but in reality, if you had to dig into this like as a NURBS model, if somebody handed you this, you'd be like, thanks, buddy. Now I have to deal with this turd. So what shrink wrap does is it allows you to be able to take that trash and turn it into treasure. And what I want to show is how that happens. All right, hopefully I spared everybody's ears there. So I'm going to select this entire thing. And what I'm going to do is just hit preview. And I am going to let it run. And then I'm going to hide the input objects. And you can look at that and say, wow, that's not great. but wait, there's more. The first thing I'm going to do is I'm not going to fill the holes in this, because you can see that it actually fills right over the finger guard. And so I'm going to uncheck that. it's going to recalculate, and it's going to recognize this is a hole. Now, the mesh is really, really coarse, and the reason for that is Shrinkwrap always tries to give you kind of a coarse mesh to start with just for performance sake. So what it's going to do is it's going to do the calculation quickly, and it's going to give you something, right, so that you can have a starting point. And in this case, the target edge length, this is referring to the length of the edges on the polygons. And in this case, this is 0.12 units, and it's way too big. And so what I'm actually going to do is I'm going to crank this all the way down to 0.01, which is the limit for this tool. And you can see that if I shut off the mesh wires, this ends up, and I shut off my ground plane. You can see that this actually looks quite good, right? So I'm going to go ahead and accept that. I'm not going to do any smoothing iterations because I don't necessarily want to lose any detail here. And the polygon optimization, what that refers to is how much decimation happens in flatter areas. So if I take this and I crank it up to like 50%, you're going to see that it's the density of the polygons are going to get much less on areas with less curvature. If I take this down to like 2, you're going to see that we're going to get much denser polygons in these areas. Now, I'm not super concerned about the optimization. I'm gonna roll this something like 5% and just go from there. That is kind of a good balance. But you'll notice that what's happening is there's a multi-density thing happening here where there's more curvature, there's more polygons. So you can play with this, and especially if you've got your own printer and you want to do some tests, what I would recommend is benchmarking yourself and saying, okay, how much optimization can I get away with? Because if we go higher, right, if I crank this up higher, what I'm going to get is a very light model. You can see that this model has lost a whole heap of polygons. And so sometimes that can be beneficial because you know there's so much computational overhead, you don't have to carry a big model and all that kind of stuff. But for my case, I really don't care at this point because my printer can handle a whole heap of polygons. And so I'm just going to go ahead and throw them in there. But what I would recommend is that you benchmark yourself, right? Print the same model or print a small piece, the little test piece, print it at like 10, 20, 30, 40, 50, 60, 70, 80, and print them side by side and see what they look like and figure out where the sweet spot is for the detail versus the, you know, the density of polygons and the, you know, walls, you know, the heaviness of the part and all that kind of stuff. So for this, I'm going to just go ahead and run it. I'm not going to do any smoothing iterations because I don't want to lose any detail. And I'm going to not delete my input object because I'm going to use it again. So let's just go ahead and run that. And then I'm going to go to my layer stack and I'm going to create a new layer and I'm going to call this, right? And I'm going to move this change object layer by right clicking, and I'm going to move that there, and I'm going to shut my main model off. Now you can see what happened here is that turd of an original model, right? That was a mess that had open stuff all over it and was junk, is now a closed mesh. And not only is it a closed mesh, but it's a good closed mesh. This is something that you could throw to a printer right now and it would print like a champ, right? So the cool thing about this is now what I can do is I can shrink wrap this again. If I run shrink wrap again, I'm shrink wrapping the shrink wrap as opposed to shrink wrapping the original model again, because this tends to work better, and I'll show you the difference. So if I offset this now, let's do it -0.1, and I'm going to offset this, and I'm going to use the same settings I had, just 0.01. I may throw a little bit more polygon optimization at it this time because I can lose a little bit of detail on the core. So let's do, I don't know, let's do 40. Let's just take a look at it. Preview. And I'm going to hide the input object. And what it does is it gives me an offset of that part, right? So if I bring the input object back, you can see that is my offset. And so what that allows me to do then is take a look at this and say, okay, now maybe I want to play with some smoothing iterations. Maybe I do 5. Just take a look at it and see what it looks like. Because some of these little giblets out here, I don't necessarily want. So I'm going to see if I can smooth those out. And they do, they disappear. And you'll notice not only that, but the edges soften just a little bit. and some of these things soften a little bit, and that's actually kind of desirable for the core side of this part. So I'm going to go ahead and accept that. And you can see if I superimpose this and if I go to like ghosted mode or X-ray mode, you can see that that does exactly what you would expect it to do. So I'm going to hide the main. I'm going to hide the main surface. And I'm going to make a new layer. I'm going to call this offset. I'm going to change this here. All right, so I'm going to bring back my main surface, and I'm going to hide my offset for now. And I'm going to shrink wrap the shrink wrap one more time. And the reason that I'm going to do that is I need an object that I can use for my lap joint. So I'm going to shrink wrap this again. And my offset was 0.01 last time. I want to go half of that. So I'm going to go negative 0.05. I'm going to leave the smoothing iterations and the polygon optimization alone, and I'm going to preview it. And I'm going to hide the input object. Now take a look at that and say, that's probably pretty good. I may smooth that just a little bit more. And I'm going to say that's probably going to be okay. So let's go ahead and okay that. And I'm going to take this part. I'm going to call this lap joint. Right. And then I'm going to right click, change object layer here. So now I've got my three pieces, right? I've got my main surface, my offset, and my lap joint. So here's my main surface. My offset is here. And then my lap joint is here. Okay. So I'm going to hide these two for the time being. And the first thing that I want to do is I'm going to split this in half, because in order to be able to core it, I want my two halves. And so I'm going to just do that with, and I'm going to go to shaded mode. I'm going to do that with a mesh box. And just in case you didn't believe me, booleans actually work now. Hard to believe. You've been with Rhino for a long time. You're going, no way, there's no way the mesh booleans work. They do. No one makes no one happier than me that these work now. And so I'm going to just pop this guy out and dock it, because we're going to use that a bunch. And what I'm going to do is I'm just going to Boolean mesh split this using this box. And we're going to just let that run. And I'm going to delete the box. And voila, we have two beautifully split parts, right? And that's super awesome. So now what I'm going to do is I'm going to go to my lap joint object, and I'm going to bring that up, and I need to actually create the little surfaces that are going to make that happen, right? And the thing that I want to do is I'm going to bring this box back, because I'm going to use it again. And let's hide these guys, and let's show the lap joint object. And I'm going to split this guy in half. And actually, I'm going to just Boolean half of it off, because I don't really want this lap joint object. I actually want this surface right here. I want this. And the way that we're going to get that is I'm going to go to Boolean edit tools, and I'm going to extract connected. And I'm going to pick this face. And the settings are less than 10 degrees. And we're going to extract that, right? And then I'm going to join it on mesh again. And then I'm going to delete this piece, which seems really counterintuitive. And so what I want to do actually, and the reason that I did this is I actually want this to be an extrusion. I don't want it to be like the actual model part itself. I want this to be an extrusion. And so what I'm going to do, I'm actually going to extrude this just a little bit. I'm going to hold down shift on the extrude dot. This is new for 8, this extrude dot. And I'm going to just pull out a little chunk, right? That gives me that. And I'm going to bring back my original objects, and I'm going to make a copy of this. And I'm going to boolean this guy into here. So this is the positive side of my lap joint, right? I'm going to bring the other guy back, hide that side. I'm going to paste a copy of this, and I'm going to boolean subtract from this side. Now, the people in the audience who are paying attention will notice this is a line-to-line lap joint, right? And most cases you can get away with this if you're using an SLA or something that's high def. If you're using a PLA printer like a Prusa or something like that, you're going to want to build a little bit of gap into here, which means that you're going to actually do two lap joints. You're going to do a negative one and you're going to do a positive one. And those two will get you what you need. Now it looks like there's a little weirdness here. Let's get rid of that. Looks like Boolean misbehaved right there. So let's take a look at that. And show the edges. We can see that. Let's just do a fill mesh hole. Fill that up. There we go. And you can see that it looks a little weird. See that? If we rebuild the mesh normals, it'll clean that up. Okay, because that's just a normal thing. Now, let's double check this and make sure that it's a closed mesh. And it looks like it's an open mesh, so let's look and see where it is. And it looks like there's a little gap down here and a little gap up here. So let's go ahead and fix those. So it looks like if we hold down Control Shift, we can delete those, and then we're gonna just fill mesh hole. And this one looks like there is something weird going on there. That. Here. Same thing here, and same thing here. So this should now be a closed mesh. It says it's still open. Let's figure out where. There's a little teeny one right here. So let's take a look at that. So about that one doesn't like it for some reason. There we go. Looks like the size of this polygon, for some reason, it didn't like that. So let's fill this one. May have been a little ambitious when I did the box. I should have probably used a little bit higher polygon count. I'm going to patch single face here. I'm going to go from here to there, and then from here to here. That allows you to be able to decide exactly how that hole is going to close. And so I want to kind of make a few little bridges here. Just patch single face, and then I can fill hole. I did a video on patching meshes, and that one, actually, let's do this. Break this up a little bit more. And if this were to misbehave really intolerably, we could actually go through and shrink wrap this again. We could just shrink wrap to shrink wrap. And it looks like we've got a few down here that's still behaving. Sometimes the way to fix a mesh is to make a bigger hole that's cleaner. Close mesh now. So that's what we're looking for. All right, so we've got our, and I'm going to just rebuild the mesh normals because I think that's probably going to render like trash. No, actually, it's all right. Yeah, we'll do this. So that's good to go. So we've got our positive lap joint and our negative lap joint, right? So we've got, look at this. We've got our pokey outy bit and our sticky inny bit. So the last thing that we need to do is we need to bring our offset in, and we just simply need to suck the inside surface out of the core. We're going to do that with a mesh boolean. And we'll hide this side. Other side back, and we're going to do the same thing over here. That's our chord part. A lap joint built in. Looks like saved. Let's see. Looks like that booleaned backwards. So let's fix that. Let's make sure this guy's closed. Oh, that one's open. So let's figure out why that's open, because that's where the boolean failed. All right, let's figure out where that one's open. Show edges is the command for that. And let's look and see. Looks like we've got a few pieces in here that need to be fixed. So let's take a look at that. I'm going to do that in rendered mode or shaded mode. Looks like the resolution on that original box that I used to do the split is probably biting me, which is regrettable, but such is life. Single face. Win, so I'm just going to Control Shift delete it. Grabbing a vertex, I would like it to grab the edge, so I'm going to do that. Pick a little bit more carefully. There we go. Mesh hole. That one I can probably get away with just filling. This one is really long and it goes around a corner, so I'm going to patch a single face where it goes around the corner so that I get a little bit more control over how that fills. Now I can fill mesh hole because I've broken it up into two kind of more logical pieces. And that's still open, so let's see where. That is, let's take a look. Stack these just for the time being. Looks like there's a weird little thing going on the inside here where my boolean failed. So let's make our life easy. Let's just shrink wrap this again. I'm going to explode this entire thing. Let's see if I can figure out where that junk is on the inside. It's like that is where the problem lies. So I tell you what, let's abandon this guy and let's make a new part from the original. See if we can't get a better result. So let's go to the main model again. Shrink wrap this. The one side works fine. So let's just make one preview. And we're going to hide the input, not fill the holes. And I'm going to drop this to 5. I think that's what we were using before. All right, say OK. Split it from the top like we did before. I may subdivide this. Get a little bit more density there. I think that might have been one of the issues. And let's get our lap joint back. So that is just a single surface, so I'm going to just extrude that out. And doing that. If that misbehaves, then what we'll do is we'll just shrink wrap the two pieces. And that looks like closed mesh, so that's good. So let's bring our offset back. In here. I think the fact that that was open before is what caused that to fail. Here we go. That's better. Close mesh. Alrighty. It's simple, really. All right, so here's our two pieces. And if we go to rendered, you can see that we've got nice cored out part here. Looks like I forgot to do the core over here, so let's do that. I'd be accused of cheating. Route part there, close mesh. So these are both good to go. Beautifully cored, beautifully shelled, with a lap joint, ready to go to a printer. Now, like what I was saying before, is this is a line-to-line lap joint, and so this fit is going to be really, really tight. What you might want to do is, if you do your lap joint, you may want to do two offsets for an outside lap joint and an inside lap joint, with just a teeny tiny bit of clearance built in there. Depending on how much you're willing to go through with a piece of sandpaper or whatever and clearance this, it may determine how tight you want to do this. But what I want to point out is that this process right here in Rhino was essentially impossible until version 8. And looks like I need to rebuild some normals here. So let's do that. This process was essentially impossible before Rhino 8, before Shrinkwrap came out. So I just wanted to show this to make sure that everybody was aware of it. And the fact that not only is Shrinkwrap a great tool for unifying, models that are kind of messy or disjointed, but what it allows you to do is to be able to actually do some modeling processes here. So things like lap joints. If you wanted to add screw bosses to this, you could build the screw bosses in NURBS. You could mesh those and then use mesh booleans to put the screw bosses in. So there's a whole lot of options as far as being able to do this type of work that wasn't available in the past. And so when you throw this through a printer, you're going to end up with a beautifully shelled part. And I actually did a test on this. I actually have a piece on my desk where I shelled this to test this process. And it actually works really, really beautifully. And the reason that voxels work better than polygons when it comes to offsetting is, if you imagine, polygons are little triangles, right? And so when you offset, if you hold your hands out in front of your face, right, put your right hand facing straight up with your fingers straight up, and place your left hand on top of it like an L, like an upside down L. Now move your top hand down and move your right hand in and let your fingers cross, right? So you're kind of knitting your fingers together. That's called a bow tie. That's called that what happens is the offset goes down, the other offset goes down, and where they cross, they connect and they go back and they bow tie on each other. And I can show you what that looks like in just with a curve, right? So if we take curve here and we imagine that we're looking at a cross section, and we take this object and I move this one down this much and I move this one over this much, which is what happens on an offset, you get this scenario right here, which is called a bow tie. This is bad because what happens is the normals are going in or out, right? But they're going in, out, 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 and then they flip to in, and then they flip back to out. And so Rhino, or any computer, is going to get really confused by that because the normals are looping back on each other. What voxels does is, imagine instead of triangles, voxels are grains of sand. And if you put voxels in a bucket on a beach, right, and you dump the bucket over, you have an object. Now, if you want an offset of that object, all you do is shave off some of the sand. So there's no bow tying, there's no offset. It basically just moves the grains of sand in and gets rid of the ones that are overlapping, which is why this process works on a really complex object like this, whereas a NURBS offset or a polygon offset would fail miserably. So that's one of the real benefits of Shrinkwrap and how that works. Now, the other cool thing about this is, let's say you're a jeweler and you have a ring that's made up of a bunch of spheres. You don't even have to Boolean those things together. You can just shrink wrap them. The shrink wrap will do the Boolean for you, and then you pull the mesh part off. Now, rearrange those spheres. You haven't trimmed them. You haven't done anything to them. Just rearrange them, make them, scale them bigger, smaller, whatever. Shrink wrap it again. Now you've got an iteration. You could do that over and over and over again, and in about a half hour, you could end up with 15, 20, 30 pieces that you could throw through a printer. So think about that in terms of billable hours in a studio, right? Now think about, like, if you had to build that ring and you had to trim and you had to blend and you had to fill it and you had to Boolean and all that kind of stuff, and then you made your part, and then you had to tear it all back apart and then you had to do it again. You'd have to remodel the whole thing from scratch, and then you'd have to do it again, remodel the whole thing from scratch. With Shrinkwrap, you can just pile stuff together, right? If we look at this model, this main model, this thing really is, kind of what I'm talking about with the jewelry. It's just stuff on top of stuff on top of stuff on top of stuff, right? And it's overlapping. This piece is completely overlapping. It's not even trimmed or booleaned or anything. It's just smashed over there. This piece is not even trimmed. This is just smashed in here. All of these things, these little details in here, none of these things are booleaned in or trimmed. They're just smashed in there. But yet we can end up with a result like this that is something that you can then throw through a printer and get really high quality results that you can then, go from there. Okay, so that's kind of the benefit of what I wanted to show for Shrinkwrap. And as in the next weeks and months here, we're going to show more and more features of version 8. There's push pull, which there's a video of that, kind of an intro video of that on YouTube as well right now on our YouTube. So if you're interested in that, you can take a peek at that. But we're definitely going to be showing a lot more of that stuff. But Shrinkwrap is, in my mind, is one of the heroes of V8 because it allows you to do something that you could not do in Rhino before. You just couldn't do it. You could not shell this part in Rhino unless you just built the model from scratch again, offset. So that I find is really exciting because, when I ran my consultancy, I had my own printers and I had all that kind of stuff. And this particular process was something that I had to have a whole bunch of other different software and a whole bunch of other different processes in order to try and pull off. Now it's all available in Rhino with Rhino 8. So that's all I wanted to show, kind of short and sweet today, but that's what I wanted to show today. And if you have any questions, by all means, let me know. Check this video out on YouTube. It will be available shortly. And look forward to having you try out V8 and let us know what you think. Any questions? If not, I'll let you go. Awesome. All righty. Thank you for joining me. I appreciate it. I'm Kyle Houchins, tech and a trainer for McNeil. Go make great stuff. Thanks. Bye.